Hello and welcome back. I'm your friendly neighborhood technician. Today, the car is snafu. If you don't know what that means, you can look it up. My YouTube channel has the word friendly in the title, so I'm not allowed to tell you. So that being said, the windshield washer sprayers don't work. So now we get to diagnose why they don't work. The wipers work, but when you push the switch in, it doesn't spray. So we're going to go through diagnosing that, and we're going to go through looking at the wiring diagram and see if we can figure out why the sprayers don't work. But before we get into that, please, if you have a second, go visit my Etsy that I have some branded merch up, even some other stuff that's not branded. Don't make fun of me. I just designed a bunch of stuff and threw it up. So some stuff I do have a Friendly Neighborhood Technician logo and another logo and another design that I created and just some random stuff. So even if you don't get anything, just follow the link right here. And if you just go visit the website, that would be fantastic. So if you can do that, that'd be great. Okay, I have not diagnosed the vehicle yet, but this was the very last brand new turn signal / windshield washer switch in the country, in the United States that is. And that is the exact reason why I got it, because I don't know if it was the switch or not. It might not be the switch, but being this is the last brand new one, I went ahead and bought it. So normal retail is probably about 160 bucks on this. So, but I figured even if it's not the switch, it can help as a visual aid for diagnosing. And you can see right here, I can use this and I don't have to take apart the one that's in the car. So I can actually show you how to even verify that this works. So if you have to diagnose yours, you want to check to see if your washer right here works, then we can go ahead and I can show you which pins to test on here using the wiring diagram, and I can show you what values you should get with a multimeter. All right, I'm going to leave this on the screen right here for a second because this is the wiring diagram for the windshield washer system. So the wiper system, washer system, you can see right here, here's the windshield washer pump. Here is the windshield washer pump switch, which is this part right here. That's your windshield washer pump switch. And then you can see your wiper blade switch, which is also a part of that switch on the stock. And then here's your combination relay and all that stuff. So I'm going to leave this here and I'm going to talk about this for a second so we can figure out, or so you can actually screenshot this if you want. And there's the wiring diagram for your washer system. Okay, step one when you're trying to diagnose something that's electrical, such as a windshield washer pump or the wipers themselves, is CTFF, which means check the fuse. And that's what that means. So that goes for basically any electrical circuit that has a fuse. Step two is go ahead and we're going to try to throw some logic at this. And before we start tearing stuff apart and before we start diving really far into this vehicle, we're going to go over this wiring diagram and we're going to basically use logic to try to rule out certain areas of this wiring diagram. So let me describe the concern of what I have going on. Right now, when you go like this, when you push the switch in to get the pump to go off, the wipers go off, but the pump doesn't spray. So nothing sprays on the windshield, but the wipers start going. So if you look at the wiring diagram here, you can basically, knowing that's how it's functioning right now, you can use the wiring diagram to kind of rule out certain things. So this is a point where I would say, slow down to speed up. So, which also means that if you slow down a little bit and you try to understand the wiring diagram and what stuff works and how stuff works, then you can save yourself money by not just throwing a bunch of parts at it. Okay, right now, so what happens when you push the switch on the turn signal stock to get your windshield to spray? You can see right here, voltage goes down here, it goes through the washer pump switch, which is what you're pushing. It goes straight down here, and then it actuates this switch right here that in turn actuates the wiper motor. And then also when you switch that right there, it sends voltage down here to spray the windshield for the washer pump. So right now we know that the wipers work. The wipers work, and when you push it in, the wipers spray. Now you also have your windshield wiper switch right here also, but when you push the wiper pump switch in, that actuates the pump, the motor itself, so the wipers work. So going by that logic, we know that the windshield washer pump switch itself is functioning because the wipers function. And you can see for the wipers to function, then this switch has to make contact. So right now, I can almost guarantee you that it's not the washer pump switch. But like I said, I did buy it just so I can show you how to diagnose it and which pins to use, or which pins to check with right here, which we're going to go over that. So using that as the logic, we can kind of narrow down where we're going to focus our diagnosis. So right now we know that this circuit right here is good because the combination relay works, which means the wiper pump works right there. So right now we have basically three different things that could cause the washer pump not to spray. One being the washer pump. The washer pump itself could be going out, or you can have this ground right here, could have an open circuit on it or an excessive amount of resistance on that ground, or this circuit right here between this X83 point and the actual washer pump itself. This can have an open circuit in it, or somewhere maybe there's corrosion or a broken wire somewhere. So either you're not going to get voltage here, so we're going to have to check available voltage, we're going to have to check available ground and see what the resistance is between the connector right here and the ground itself. Maybe there's a lot of resistance, and maybe right here we're just not getting the voltage to it. So that's a possibility also. Okay, let's say for example that your windshield washer pump or your windshield wipers aren't working at all. We can use this wiring diagram to check that also, and I'll show you what values you should get when you're trying to check that, the function of this switch right here, which you can use the connector right here. If you can access it, you want to crawl underneath your dash and use this connector to access it. You're going to check pin 11 right here, and you're going to check pin 10 right here, which are right here. You can see there's pin 11 and pin 10. So we're going to check resistance between these two. And when you when you're not actuating the switch, you should get an open circuit. And when you push the switch in, you should get very low resistance, because what happens when you push the switch in, that closes the circuit, and you should get very low resistance right here. But the switch not being pushed, it's open right here. So you should get an open circuit between those 2 points. Okay, so one thing I want to point out, if you're not familiar with multimeters and you're not familiar with how they work and what they actually do, is one way I like to look at it is when you're measuring voltage, for example. So let's say you're going to measure the voltage between here and you're going to measure that to ground when you're actually trying to push the switch or something like that, or you're trying to check another point. How the meter works is it doesn't actually measure voltage. It measures the difference in voltage. So when you're going to pick 2 points on a circuit, you're going to you want to check available voltage. You're going to check the voltage at a power source, and you're going to want to check it at the ground. And that's how you're going to measure the difference in voltage. The difference in voltage between the power that you're trying to measure and the ground should have no voltage on it if it's after a load. You should get the difference between that, which a lot of cases is going to be battery voltage. So that's how that works. So if, let's say you take measure voltage here, and let's say you have 12 volts going through this wire right here. You measure voltage here, and then you have a break in the wire and you measure voltage here. So you're measuring here and here. Your voltage, even though you have 12 volts available between here and ground, right there, if you measure between here and here, you're basically gonna have 0 volts, because there is no difference in voltage between this point and that point if there's no load between those points. Okay, so right now we're going to set this to resistance, just like that. Now you can see open circuit, OL out of limits, and you can see right here that it's not actuated. So right now between pin 10 and 11 right there, I believe that's pin 10 and 11. I guess we'll find out right now. When I push this in, that should go down to less than an ohm, preferably less than half an ohm. Probably going to be 0.3 to 0.4. Right there, 0.4 of an ohm. So really low resistance. See 0.3 right there, 0.2. Yeah, very low resistance, because like I said, you're basically completing that circuit right there, and you're gonna have, and right there's just an open wire. So when you have a good circuit, you should get very low resistance between 2 points if it's, again, not going through a load. Okay, so right now we're going to check for available voltage at the connector with the violet and yellow wire, which you can see right there, violet, yellow, and the brown is going to be ground. So we're checking between that first pin right there, and you want to find a good ground when you're doing this so you get accurate measurements. So you can try right there. If you can't find another good one, but you should be able to find a better one. This will ground also, but there's a little bit more resistance right here than using an actual ground, such as one of these points right here. You have 2 ground points, 3 technically, at this one right here, this one, this one. These are all grounds. So you can use any number of these on these points right there, and you'll get a good ground, and you'll get an accurate reading. So right now I'm going to go turn the key on, and then I'm going to actuate the washer pump, and you're going to see if we get any voltage. So you just saw there that we have 12 volts. So we know the voltage is good right there. Now we're going to check, just for shits and giggles, we're going to check the other voltage, or the voltage to the other pump. We're going to see if we get any voltage right there. Okay, as you just saw, there was no voltage at the other pump, which this pump is the washer pump for the headlight sprayers, for the little headlight wipers. So we're not getting any voltage at the other pump, which is the pump right here. That's for your windshield, that's for your headlights right there. So that's a separate concern. So now I know those don't work. I mean, I can't really tell if they work because I'm sitting in the car when I'm turning them on. But now I can tell that they don't work because they're not getting any voltage. All right, now what we're doing is we're checking resistance between the ground wire right here, the brown one, for the wiper with no voltage, and the ground over there, which you can see has really low resistance. But check this out. .2 ohms of resistance between the power wire and ground. The resistance should be open circuit right there. There should be no contact between power and ground for the power wire. That's pretty much a direct short to ground. So that's another concern that we need to figure out, because I don't want to have direct short to grounds on any kind of wiring on my car. Now what we're looking at is we're measuring the resistance between ground, the ground wire of the windshield washer pump, and directly to ground. And you can see it's an open circuit right there, which that's not good. That should have very low resistance. So we can already tell, at least on this circuit for the washer pump, that our concern is going to be a lack of a proper ground. You can see right there. So between that pin right there and ground, wherever it grounds, is a break in the wire somewhere. Okay, I'm either the luckiest guy in the world or the unluckiest, or both at the same time, because I'm lucky because it was easy to find. I'm unlucky because of where it is. Now, if you look right there, look at that. Bare wires. And as you can tell, it's not exactly the easiest place in the world to fix. So washer reservoir's got to come out, and then we got to get in there and either probably going to repair those wire sections, so we're going to need some solder connectors, and then hopefully we'll have both these washer systems working. Okay, so I got a little bit better access to it by removing this grommet down here, right here, and you can see right there what looks like rodent damage. And it looks like it's going all the way down there as well through the grommet hole. I can access this portion of it, but I can't even get down there to the other part. So there's a lot of damage to these wires right here. So a section of this is going to have to get replaced. Yep, you can see all those chewed wires right there. Okay, so what we get to do now is we get to remove this headlight, because there's still not really enough room down there to get all the wiring out, and there's more damaged wiring down below. So we need to take this headlight out so we can actually get to the all the wiring. Okay, step one, we got to remove the wiper, and this just pulls down, and then you can see there's a little 8mm nut. So we got to pull that nut off, and then we got to pull this little hose out. Next, what you're going to want to do is remove this whole side marker lens. Now, there is a tab that goes straight back. You can get to it from inside the headlight housing right here, and you have to pull it towards the inside of the car that way. And you're gonna have to pull quite a bit because there is a little metal, flat sheet metal spring that's gonna pull against. So you may or may not feel like you're gonna break it, but you have to pull it inwards, and then this will come straight out. And then you can unplug the connector, and that's it. You can see, here's that tab right there. There's a little sheet metal spring you're gonna be fighting against. It's gonna go like that. And you do have quite a bit of lip right here that you have to release just to get this removed. Okay, next we have 3 bolts that we have to remove. We have this 8mm right here, then we have this 8mm right here, and then we have this 8mm right there. And we also have one more 8mm right down here. Now we can remove this cover. Don't forget to remove or detach the hose that attaches to the inside of this. Next, you're going to turn this 90 degrees to the right, so where the channel is facing like this, and you're going to pull it out. Then when you put it back in, you put it in, then you turn it 90 to the right. Now right here, between the headlight and the fan, you see there's one more little 8mm bolt right there, so take that out. Now, at least according to the work instructions, you should be able to remove your headlight. And don't forget, you will have to disconnect the connector that's over here. Just like that. Now you may, if you have wipers, you may have to finagle it out a little bit with the motor right here. Now we got to remove that, which is just a bunch of 8s. One there, there's one up here, and then there's one right here. Next, remove this little piece of foam from right here. Next, I'm going to work it out. Now we can really see to the extent that the wiring is damaged. You can see some of the power wire right there is damaged for one right there. A lot of this other one right here is damaged as well. So we're going to know you need to go ahead and repair this. Now to give yourself a little bit more room to work with, you're going to want to release this zip tie right here. Now we're going to have to trim off this sheath right here, and we're going to have to trim off some of this sheath up here so we can get access to a little bit more of the wiring so we can actually install some solder connectors. Okay, now that we have both of the connectors for the washer pumps figured out or separated, you can see that the damage is all in this one. So the other one doesn't have any actual damage. So we may, which this one right here is the one for the headlight washer. So we may or may not have another issue with this circuit right here. But let's fix what we can see right here, and then we'll test and we'll see what happens. Now we're going to snip out the damaged section of wire. Okay, so there are many ways to perform a wire repair. There's not one right way. There's a bunch of wrong ways, but there's not one specific right way. So this is the connector that we just cut out, and I have stripped the insulation off. Now I have two different solder connectors. This is the Amazon solder connector, which came from a kit that has about 170 pieces in it for about $11, or the Mercedes solder connector that is about $20 each. So right now, if I use these $20 each solder connectors, I'm going to need 4 because I have to put a piece of wire between here and there. And so I'm going to need 4 of those. It's going to be $80 in solder connectors, or I can use maybe 7 cents worth of solder connectors. So I'm going to go ahead and use these. Are these ones better quality? Yes, but I don't feel like spending $80 just to repair 2 wires. So have I ever had one of these fail? No. So one thing you always want to double check to make sure you have low resistance. That's how you're going to verify that the repair is done correctly. So we're going to go with these. Okay, so now when you're going to use a solder connector like this, the rule of thumb that I like to use when stripping the insulation off the wire is you want to use more or less, you want to strip more or less the amount of insulation that's going to go between the seal right here and the seal right here, so the seal can actually get on some insulation. You don't want to strip too much, then your wire is going to be poking past the seal. You don't want that because this red piece, those 2 red pieces need to seal against this insulation. So you'll notice that with the piece I have right here in my hand, this is a fat wire, this is a skinny wire. That's okay, you just don't want to go from a fat wire to a skinnier wire. You don't want to use a smaller wire than you started with. So large is okay, this is what I had on hand. So when you're going to use a solder connector, what you don't want to do is you don't want to strip this and then twist these ends, because you don't want to do that, because what you want to do is you want the wires, the strands of the wire inside here, you want them to mesh together. Kind of like that. So you can see how this one is kind of open like that. So when you put it in the solder connector, the strands of the wire will mesh together kind of like that. Even more so than that. But you get the picture. They should mesh together straight like that. And then when you melt the solder on the solder connector, it's going to solder all this together. And it's going to be nice and slim. And you're not going to have any big knots and stuff like that. So when you use a solder connector, you don't want to do any fancy twists. You don't want to hook it around and hook them together, anything like that. If you're just going to use straight solder, yeah, by all means, do what you got to do to get the wires to stick together. But with a solder connector, that's not necessary. Okay, let me give you an example. You can see right here how you can see the insulation of the wire through the solder connector, and you can see how it stops right there, and then the wire also stops right here just before that seal. So you're going to have as much area as you want for the solder to melt, and then when you put this wire in this end, you're going to make sure you get it all in there. And then when you slide it together, they mesh just like that. And there'll be a point to where you can't really mesh them together any further. But then you can see also right here, the insulation is right there, the insulation right there, and everything is meshed together perfectly. Now we can go ahead and solder this together. Now, just like performing a wire repair, there's not a right or a wrong way to do this. Some people use a lighter. I use my soldering torch with the little air deflector on the end. I usually set it to medium because too high, it kind of burns real easily. I like doing the ends before I do the actual solder. Just like that. Then when it cools down, it gets less clear, and now it's great. So now, if you can see what I did here, I used black wire for the ground and red wire for the power. I didn't just use 2 lengths of the same color wire. I mean, you can figure it out. At least your ends are still the same right here, so you're not changing the end of the colors, end of the wire. So if you did have another issue, it's easier to figure out which wire's power, which wire's ground. But if you ever had an issue in this area and you needed to remove the insulation or the sheathing from these 2, you can tell, okay, power, ground. You know, just out of a moment of sheer curiosity, this is the circuit that we didn't repair. Remember how these two had 3.4 ohms of resistance to each other? You can see I still don't have the other wires in here. These are still just separated and disconnected away from each other. But now, you can see right here, I don't have continuity between these two anymore with that damaged section of wire out of here. And also, I don't have any continuity on the power wire to ground, and on the ground side, I have 0.4 of an ohm, which is really good. So it looks like doing this one wire repair, we fixed both circuits. Okay, one thing I did think of, if you have any kind of foam tape or anything like this, I do want to recommend re-putting that seal around there. Especially if it's old, it's just going to come off. There's no way to reattach it, except maybe get some kind of foam tape and put it back around there. All right. Now that it's all back together, let's give it a shot. Hey, they work. Need to be adjusted a little bit, but I'll take it. All right, so the windshield sprayer is fixed. So the diagnostic process we use for that can be used for quite a few different electrical circuits, and it's all going to be the same as long as you know the values that you're supposed to get, and you can get to the points there, the different connectors and the points, and you know how to measure between power, ground, stuff like that. You can figure out pretty much anything on these cars. So thank you for watching, and make sure you give me that thumbs up, hit subscribe, and hit the notification icon when you so you get a notification when I post a new video. And if you can, again, please go visit the link in the description below, my Etsy, that'd be much appreciated. Thank you for watching.